Okay, here's the thing. Number 7. The wow signal. In standard radio astronomy, signals from space are wide. They spread across thousands of frequencies. The natural output of stars, gas clouds, magnetars. This is basic physics. Radio waves from natural sources don't narrow themselves. They don't choose one precise frequency and broadcast there. That's not how the universe works. That's how technology works. But on August 15th, 1977, astronomer Jerry Amen was sitting at Ohio State University, going through printouts from the Big Ear radio telescope, routine volunteer work, scanning columns of numbers, when one sequence made him stop. He picked up his red pen. He circled it. He wrote one word in the margin. Wow! What he'd found was a narrowband signal at exactly 1420.456 megahertz, the precise frequency of neutral hydrogen. That's not a coincidence. In 1959, physicists Philip Morrison and Giuseppe Cocconi had published a paper theorizing that any civilization trying to contact another would logically broadcast at the hydrogen frequency, because hydrogen is the most common element in the universe. Every civilization, anywhere, would know it. It would be universal calling card. The wow signal hit that frequency like a dart hitting a bullseye. It was 30 times more intense than the surrounding noise. It lasted exactly 72 seconds, the maximum possible window the Big Ear could observe any point in the sky, given Earth's rotation. Think about that. It didn't cut off early. It didn't start late. It filled the window perfectly, as if whatever was transmitting knew exactly how long it had. But it gets worse. Emen and his colleagues pointed Big Ear back at the same spot, 50 more times over months. Nothing. Other telescopes, more sensitive than Big Ear, searched for years. Nothing. The signal appeared once at exactly the right frequency, at exactly the right intensity, behaving exactly as we would expect an alien transmission to behave, and then vanished, like it had said what it needed to say. If you were sitting in that observatory in 1977, scanning paper printouts by hand, you would have no idea what you were holding. A sequence of letters and numbers, 6EQUJ 5. It looks like a password. It looks like a code. You'd circle it and write, wow, and go home. And 48 years later, no one on Earth would have a better answer for what it was. These signals are the universe's unanswered letters. They arrive once. We don't know who sent them. We don't know if there will be another. Number 6, BLC-1, the signal from our nearest neighbor. In radio telescope science, narrowband signals confined to a very tight frequency range, almost never come from nature. Stars broadcast wide. Cosmic events broadcast wide. The only things we know that produce a tight, narrow signal drifting slowly in frequency are transmitters, artificial transmitters, built by something that understands electronics. On April 29, 2019, the Breakthrough Listen project, a $100 million, decade-long search for alien technology funded by Yuri Milner, was conducting routine observations of Proxima Centauri using the Parkes Radio Telescope in Australia. Proxima Centauri is 4.2 light-years away, the closest star to our sun. It hosts at least 2 known exoplanets, one potentially in the habitable zone. An undergraduate intern named Shane Smith was going through archived data in late 2020 when something jumped out at 982.002 megahertz. He flagged it. The team stopped what they were doing. The signal, BLC-1, Breakthrough Listen Candidate 1, was narrowband. It appeared only when the telescope pointed at Proxima Centauri and not when it looked away. It persisted for over 5 hours of observations. And here's the part that made Dr. Sophia Sheikh at Penn State lose sleep. It was drifting in frequency, exactly the way a signal would drift if it were being transmitted from a planet in motion, a planet orbiting a star. It was like watching a Doppler shift in real time, the signature of something moving through space. Andrew Simeon, principal investigator of Breakthrough Listen, said it plainly. BLC-1 represents the best candidate signal we have had in the Listen program since beginning in 2015. But it gets worse. The drift was going the wrong direction. When Dr. Sheikh analyzed the data, the frequency was rising, like a slide whistle, when standard models predicted it should fall, like a trombone. No natural explanation fits both the narrowband behavior, the directional lock-on to Proxima Centauri, and that backwards drift. None. Imagine you're the researcher who first sees this signal highlighted on your screen. It checks every box. Narrowband? Yes. Direction confirmed? Yes. Frequency drift? Consistent with orbital motion? Yes. You would feel something shift in your chest. You'd make sure the door to the lab was closed before you said anything out loud. After 2 years of exhaustive analysis, the Breakthrough Listen team concluded BLC-1 was most likely human-made radio interference, the most sophisticated interference they'd ever encountered, an accidental signal that mimicked every characteristic of extraterrestrial technology with near-perfect fidelity, most likely, not certainly. They still haven't found the exact source, and when they pointed the telescope back at Proxima Centauri, BLC-1 was gone. We are scientists who built instruments sensitive enough to hear a whisper from 4 light years away. We heard something. We still don't know what it said. Number 5. Tabby's star, the light that shouldn't flicker like that. In stellar physics, when a star dims, it dims predictably. A planet passes in front. The light dips by a fraction of a percent, a small circular shadow, perfectly timed, perfectly repeating. NASA's Kepler Space Telescope was built specifically to detect these tiny, regular dips. That's what a planet looks like from a distance. Clean, predictable, small. In 2015, astronomer Tabby Boyajian, then at Yale University, leading a team of citizen scientists through Kepler data, found a star that wasn't doing any of that. KIC 8462852, 1470 light-years from Earth in the constellation Cygnus. It wasn't dimming by 0.5%. It was dimming by up to 22%. And not in a clean circle, in irregular, jagged, unpredictable shapes, sometimes for days at a time. Boyajian said it herself, stars just don't do that. Standard stellar models have no natural mechanism for a 22% irregular brightness drop. Planets don't cause it. Dust clouds don't cause it. Dust dims all wavelengths of light equally, and Tabby's star showed wavelength-dependent dimming, meaning something with structure was blocking the light unevenly. Comets don't cause it. And beyond the individual dips, historical records showed the star had dimmed by about 20% overall between 1890 and 1989. Something had been getting in the way for over a century. Penn State astronomer Jason Wright was one of the first to say publicly what many were thinking. This star was a strong candidate for a Dyson swarm, a megastructure. Thousands of orbiting panels or collectors built by a civilization to harvest stellar energy, blocking the light in overlapping, irregular patterns as they moved across the face of the star. Imagine standing at a telescope at the Las Cumbres Observatory Network, watching in real time as Tabby's star dims and recovers. You're watching 4 separate dimming events, named Elsie, Celeste, Scarabri, Anchor, each a different depth, each a different shape. You check wavelength data. Blue light drops more than red light. Something with fine structure like lattice panels is crossing between you and that star right now, at this moment, 1470 light-years away. But it gets worse. Scientists have not found a single explanation that accounts for all the strangeness simultaneously. Dust explains some dimming, but not the historical 100-year fade. Comets explain nothing. The megastructure hypothesis explains the irregular shapes, but was ruled out, except that the ruling out only addressed the long-term dimming, not the dramatic short-term dips. In 2024, no published paper fully explains every anomaly. Boyajian herself says the mystery isn't solved. It's just less exciting in the press than it used to be. The universe is not obligated to make its engineering visible to us. If something is being built around that star, 1,470 years of light travel time means the construction may have begun before England had a written language. Whatever they're building, they've been building it longer than most of our history. Number 4. Oumuamua. The visitor that didn't behave like a visitor. In orbital mechanics, every object in space follows predictable rules. Newton's laws, gravity, and momentum. A comet passing through our solar system will accelerate as it approaches the sun and decelerate as it leaves, and if it's venting gas, outgassing as all comets do, there will be a visible tail, a plume, a detectable spray of material. Every comet in history has done this. It's not optional. It's chemistry. On October 19, 2017, astronomers at the University of Hawaii's Pan-STARRS telescope spotted something unusual, an object moving through our solar system on a hyperbolic trajectory, meaning it had come from outside, from interstellar space. The first interstellar object ever detected passing through our solar neighborhood. They named it Oumuamua, Hawaiian for scout, or first messenger from afar arriving. It was up to 400 meters long and tumbling every 7.3 hours, with a brightness that varied by a factor of 10, suggesting a shape wildly elongated, like a flat disc or a cigar. Unusual, but not impossible. Then, in 2018, astronomers published data in the journal Nature that stopped the field cold. Oumuamua was accelerating, not decelerating as it left our sun, accelerating, speeding up at a rate of roughly 5 micrometers per second squared as it headed outward. An anomalous non-gravitational force was pushing it. Here's why that's terrifying. The only natural explanation for that acceleration was outgassing, the same venting that all comets do. But there was no outgassing, no tail, no detected water, carbon dioxide, or any gas whatsoever. The Hubble Space Telescope watched it closely. Nothing. Harvard astronomer Avi Loeb and colleague Shmuel Bialy published a paper in 2018 proposing what the data appeared to require. If the push came from solar radiation pressure alone, the object would have to be extremely thin, less than a millimeter thick, hundreds of meters wide, like a sail. Nature doesn't usually make objects as thin as a sheet, Loeb noted. So why not consider an artificial origin? Imagine you're tracking it on radar, watching the numbers update. The trajectory files say it should be slowing down. It isn't. It's speeding up. You check the instrument calibration. You check the data pipeline. You check again. The math says something is pushing this thing, and there's nothing there to push it. No helium gas, no tail, no engine, no visible mechanism. It was moving at 54 miles per second at closest approach. Within weeks, it was gone. Too far and too faint to observe. No spacecraft in history was positioned to intercept it. We had one window. It closed. Whatever Oumuamua was, it passed through our solar system once, behaved in ways we cannot fully explain, and left without looking back. Or maybe it did look back. We wouldn't know. We are the civilization that landed on the moon before we finished building the telescope that could have answered this question. Timing matters. We missed it. Number 3, FRB 180916, the cosmic clock that fires on schedule. Fast radio bursts, FRBs, are some of the most powerful events in the known universe. A single burst can release more energy in a few milliseconds than our sun produces in an entire year. Since their discovery in 2007, astronomers assumed they were one-time cataclysms. Exploding stars, colliding neutron stars, a single detonation that happens once and is never repeated. Nature doing what nature does, catastrophically and without repetition. But in 2016, FRB 121102 repeated. That alone was strange. Then, in January 2020, the Canadian Hydrogen Intensity Mapping Experiment, CHIME, a radio telescope array in British Columbia, published data on FRB 180916, a repeating fast radio burst located in a spiral galaxy 500 million light-years from Earth. They had been monitoring it, and what they found was not a random scatter of bursts. It was a calendar. For exactly 4 days, the source fires off radio bursts, sometimes hourly. Then silence for 12 days. Then active again for 4 days. Repeat exactly every 16 days, like clockwork. The signal is so regular that CHIME researchers can predict it, not approximately, precisely. And then a second FRB, called FRB 121102, was found to have its own cycle, 90 days active, 67 days silent, repeating every 157 days. Jodrell Bank Observatory's Lovell telescope confirmed it in 2020 using 32 separate burst detections. Here's why that's terrifying. Natural catastrophic events don't follow schedules. Supernovae don't take 12-day breaks. Colliding neutron stars don't fire and pause and fire again in a 16-day loop. The proposed natural explanation, a precessing neutron star wobbling like a top, doesn't fully account for the regularity. Astrophysicist Avi Loeb, after studying FRB data, published his analysis. Fast radio bursts are exceedingly bright given their short duration and origin at great distances, and we haven't identified a possible natural source with any confidence. An artificial origin is worth contemplating. Imagine you're an astronomer with a telescope pointed at a galaxy 500 million light-years away. You set an alarm. Not because something might happen, but because you know something will happen at a specific time, on a specific day, because it always does. You watch the burst arrive on schedule. You write down the time. You schedule the next observation. You are, in that moment, waiting for a signal the way you would wait for a phone to ring. It's like receiving a fax from a billion years ago, arriving every 16 days, containing nothing but the fact that someone is still sending it. We don't know what natural machine in the universe sends a scheduled broadcast across 500 million light-years. We have never observed one before these two. We are very confident they exist. We are not confident at all about what they are. Number 2, SETI at home shortlist. The 100 candidates no one can explain. In radio astronomy, when you search for signals from space, you expect noise. Interference from satellites, from human transmitters, from pulsars, from magnetars, from 1,000 natural sources we already understand. The entire challenge of SETI, the search for extraterrestrial intelligence, is finding the one signal that doesn't fit any of those categories, the one that can't be explained. For 21 years, the SETI at Home project ran the world's largest distributed computing experiment. Millions of volunteers donated their computers' idle processing power to analyze radio data from the Arecibo Observatory's 305-meter telescope in Puerto Rico, the largest dish telescope ever built. Before its collapse in December 2020, the project scanned the Milky Way near the 21-centimeter hydrogen wavelength. The same frequency, always the same frequency, because any civilization, anywhere in the galaxy, would know to look there. In 2025, a team supported by the Max Planck Institute for Gravitational Physics published their final analysis in the Astronomical Journal. They had sifted through data representing 12 billion individual signal detections. After eliminating Earth-based interference, satellite noise, and every known natural source, they whittled the list to 1 million candidates. Then to 1,000. Then to 100, the top 100 signals in the dataset that could not be attributed to any known source, natural or human-made. Eric Corpella, SETI at Home project director, said it plainly: "We are, without doubt, the most sensitive narrowband search of large portions of the sky, so we had the best chance of finding something." They found 100 somethings. None confirmed. None explained. Imagine being handed a list of 100 radio signals from our galaxy that no one can account for. Not one or two, 100. Each one a direction in the sky, a frequency, a signature that survived 21 years of attempts to dismiss it. You don't know if any of them are real. You don't know if all of them are. You sit with that list and you understand that this is where science ends and something else begins. The part where you have to admit that unexplained is not the same as impossible. But it gets worse. These 100 signals were pulled from data collected by a telescope that no longer exists, from a sky survey that ended in 2020, at a sensitivity level that has never been matched for the specific region studied. If any of those signals ever repeat, there is currently no instrument positioned to detect them the same way Arecibo could. We spent 21 years building the most sensitive ear we'd ever turned toward the sky. We found things we couldn't explain. Then the telescope fell down. Number 1, Oumuamua's cousin. 3, I-Atlas, and the direction it came from. In cometary science, when an interstellar object enters our solar system, it comes from a random direction. The universe is vast and isotropic, equally distributed in all directions. There's no reason for multiple interstellar visitors to arrive from the same region of sky. There's no alignment expected, no corridor, no preferred lane. The probability of 2 or more unrelated interstellar objects appearing to originate from the same angular region of sky is vanishingly small. Astronomy doesn't deal in coincidences at that scale. On July 1st, 2025, the Atlas Survey Telescope detected a new interstellar object entering our solar system. Designated 3I Atlas, the third confirmed interstellar interloper after Oumuamua in 2017 and Borisov in 2019. Unlike Oumuamua, it showed cometary activity, jets of gas, a visible halo. Most astronomers were satisfied. Natural comet. Moving on. Then Avi Loeb, founding director of Harvard's Black Hole Initiative and head of the Galileo Project, published his observation. The inbound direction of 3I Atlas was near the sky coordinates of the 1977 WOW signal, the same general region of the constellation Sagittarius. The same part of the sky where the only signal in 50 years of SETI that ever came close to an official "this might be real" reaction originated. Loeb called it curious rather than conclusive, but he published it. Because in science, you don't dismiss curiosities that arrive from the same coordinates as 47-year-old mysteries. The WOW signal came from that direction. Oumuamua came from a different direction, the constellation Lyra. Borisov from yet another. But 3I Atlas and the WOW signal share a neighborhood in the sky. If something in that direction has been sending things our way, signals, objects, probes, we would have detected the signal in 1977 and started receiving the physical visitors starting in 2017. That timeline fits inside one human generation. Imagine you're drawing lines on a star map. A signal in 1977 from Sagittarius. No explanation ever found. Then, in 2017, an object from a different direction, behaving impossibly. Then, in 2025, another object, this time from the same region as the signal. You connect the dots, and you realize the map is starting to look like it has an author. You don't know who, you don't know why, but 3 data points in the same region of sky, across 48 years, is no longer a coincidence that feels comfortable. We are children who have just started receiving mail from an address we don't recognize, written in a language we're only beginning to decode. The letters have been arriving since before most of us were born. We have been opening them very slowly. We have not yet written back. And we don't know if we should. These 7 signals are not proof. But they are not noise either. They are the universe doing something subtle, leaving marks, or waiting to see if we're paying attention. 50 years of searching, and we still can't explain a 72-second radio pulse from 1977. We still can't explain why an object from interstellar space accelerated as it left. We still have a list of 100 unidentified signals from our own galaxy sitting in a database. The answer, whatever it turns out to be, will either be the most comforting or the most disturbing fact in human history. Either we are alone, which is vast and silent and terrible, or we are not, which may be worse. If you want to keep staring into the void until it stares back, hit that subscribe button.